Okay, 7-3, we are talking today specifically about similar triangles. And by the end of the video, you should be able to prove certain triangles are similar either by angle, angle, side, 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 or side angle, side similarity. So I'm going to put little tildes there. Remember, this little tilde means similar. And remember, we learned already that similar means that their corresponding angles are congruent to each other and that their corresponding sides are similar, proportional, similar. Okay, great. And so we're going to talk specifically about similar triangles today and these 3 shortcuts. And then we're also going to use triangle similarity to solve problems. So there are, just like in congruent triangles, there are similarity postulates, I guess you could say. So on your cheat sheet, you can write SSS, SAS, and angle, angle. And you guys should be pretty familiar with side, 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 and side, angle, side. The only difference is that we're not proving triangles are congruent, we're proving them similar, and that's why I wrote these similar marks on them. So for side, 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 as you can guess, that means that their sides are not, something about the 3 sides, and it doesn't say that they are congruent, it says that they are similar. So for example, for my hypothesis, I'm going to write this down here. Oh, I need 2 triangles. Okay, here's another triangle. Okay, let's call this triangle ABC and DEF. Okay, if I tell you that side AB and DE are proportional to the ratio of side BC and EF, and it's also proportional to the side AC and EF, then we know that the triangles are going to be similar. So we don't have to prove all 6 things like we were doing yesterday or the day before. Okay, so we just know about the sides, and automatically it's guaranteed that those angles, those corresponding angles, are going to be congruent to each other, and those triangles are going to be similar. Okay, and I wrote my my proportional sides like this. I could have done numbers. So let's say, for example, these side lengths are 3, 4, and 2. Even though it doesn't really look like it. Let's say they're 2, 3, and 4. Let's say, and these ones were 6, 8, and 4. You can see, okay, well, all I'm doing is I'm doubling each side. 3 times 2 is 6, 4 times 2 is 8, 2 times 2 is 4, so they are proportional. And we don't always have the numbers, and so this is how we write it when we don't know the numbers. This is how we can show that the sides are proportional. So all the sides are proportional, then the triangles are going to be similar. So an example of that would be like the one I gave you. Another example could be a non-example. Let me give you a non-example. So something that's not correct. Something that's not correct would be something like, let's say I had 2, 3, 4 again. And let's say I had 4, 4, oh gosh, what am I doing? Brain fart again. Okay, 4, 4, and 7. Okay, these are clearly, if you match up the sides, the corresponding sides, they would not be proportional. They would not have the same similarity ratio. So this is a non-example. For SAS, remember this A has to be included. It has to be in between those 2 sides that we do know about. So an example, let's say I give you guys something like, I'm going to give you a harder one. Let's say I give you a bow tie, kind of, an off-centered bow tie. Okay, and then let's say these are 4 and 8, and these are 3 and 6. Actually, I don't know if those are congruent. Those are similar or not. Whoops. Let's not do 3 and 4. 3 and 6. Sorry. Let's do. Sorry, that's neat. Let's do 1 and 2 instead. Okay, so are these triangles going to be similar? And I'm going to title them A, B, C, D, E. Okay. Sorry. The SAS similarity says that we need to have 2 sets of similar sides. So in this picture, we could say AC should be, let's see, AC is a larger side, so that should be similar to this triangle's larger side. So that would be CE. It's hard for me to see. CE. and those should be similar, have the same ratio as the other side. So BC, and let's see, that's a shorter side, so it should be corresponding to this shorter side, CD. And let's see if that works. 8 over 2, is that similar to 4 over 1? Absolutely, they have the same similarity ratio. SAS talks about not only the sides, but also we need to have that included angle should be congruent to each other. And we do know that those are congruent because of vertical angles. So we know angle ACB is congruent, has to be congruent to angle CED. So therefore, we know that those triangles are going to be similar. So that means that we know that these other sides will have to also be proportional and that these corresponding angles will be congruent as well. So let's see, I'm going to go ABC. Triangle ABC is similar to, let's see, I went A to B to the first one. So EDC. Okay. Yeah. Sweet. Okay. A non-example would be if these sides were not proportional or if those angles were not congruent to each other. So, for example, let's say I did 4 and 8 and 1 and 2. Again, now let's say this one was 30 degrees and this one was 20 degrees. These would not be similar. Not similar. Just like these ones are not similar. Okay, one we haven't talked about in congruent triangles is angle, angle. Angle, angle means if we know two corresponding angles are congruent, then the triangles are going to be similar. So an example would be, let's say I told you that this angle is 90, so we have two sets of 90 degrees, and then we have a 30 degrees here and a 30 degrees here. Well, remember by the third angle theorem, these angles have got to be congruent to each other, and these sides will always be proportional, always. They could even be congruent for all you know. But so they don't prove that they're congruent, but they do definitely prove that they have to be similar. A non-example would be when the angles are not congruent. So let's say this one was 30 degrees again, but this one was only 40 degrees. These triangles would not be similar. Okay, all right, so what you're going to be doing is you're going to be verifying triangle similarity. So explain why the triangles are similar and write a similarity statement. So these ones would be, should be, we have a side angle side, side angle side, so they should be similar by side angle side, but you need to verify it. We have congruent angles, sweet, but let's see, this shorter side, JH, should be proportional with this shorter side, DE. And this longer side, KH, should form with this side, and we just plug in 1 over 2. Does that equal 2.9 over 5.8? Yes, it does. We verified. You can verify by putting this into your calculator or cross multiplying. It doesn't matter to me. So we know that those triangles are similar by SAS similarity, and then you would just have to say triangle DEF is similar to, let's see, DEF HJK. So that's what I'm looking for here. Very similar to what we've done before. You just have to look out, remember again, look out for vertical angles. So these would be similar by angle-angle similarity. Also, something to be aware of is, besides vertical angles, parallel lines. Parallel lines, think about those alternate interior angles. Okay, we can actually use similar triangles to find lengths. So let's say, for example, I give you this picture. We're not necessarily sure at first, I guess, if they're similar or not. So let's think about it. Could it be SSS, SAS, or angle-angle similarity? All these are similarities. So we don't know about all the sides, so it can't be SSS or SSS necessarily, or SAS really. So let's look and see if it could be similar by angle-angle. Well, if you look at these triangles, both triangle ABE, that's the one. These are the ones that we want to prove similar, and ACD. To prove that they're similar, we can use angle-angle because both of them have angle A in there. So angle A is congruent to itself, so they are similar by the angle-angle similarity. We have angle A is congruent to angle A, and we have their two right angles. Sweet. So since they have the same angles, they have to be similar. All right, so now to solve it, we can just set up a proportion. So 5 over 9 equals x over 3. Cross multiply and solve. This is an easier problem. This one's a harder problem because let's say I wanted you to solve for side length ST. Now, if you notice, ST is only part of a triangle. It's not the whole side of a triangle like this one was. But we still are going to set it up very similarly. First of all, these triangles are also similar by angle because they have one set and they both share angle R. Sweet. So they're similar by angle similarity. Now to set up my proportion, again, I'm thinking about this yellow triangle, triangle RSV. It should be similar to triangle, let's see, R and S, R and T are the same angles, okay, RSV and RT, RTU. I'm looking at this huge triangle, the big triangle. So now I know my similarity statement, and I can begin to use proportional sides. So, for example, RS should be similar, is corresponding to RT. And now I can use the other sides another side. So let's see, I know about SV. So SV is proportional or corresponding, sorry, to TU. Now that I have my proportion, I can plug in. RS is 10. RT is, that's kind of weird. I have an X. Well, that's 10 plus X. Right? To get this whole thing, I have to add those two together. And then SV is 8 and UT is 12. And now that I have this, I can cross multiply and solve. Remember, you need to distribute this 8 into everything. So 10 times 12 is 120. 8 times 10 is 80. And 8 times x is 8x. And that's how I can solve for that one. We are also going to be doing proofs, and we can do this one tomorrow in class. I want you to also get excited for the fact that we now know pox, we now know pose. We've been talking about those all year, excuse me. This chapter we started talking about poise. Remember, property of inequalities. So we have property of congruence, property of inequality. I'm sorry, property of equality. We have property of inequalities. And now we have, because we're talking about similarity, we have some posses, I guess we could say it. So property of similarities. So we might use those in our proofs, and something to look forward to. Let's see, before I leave you, there is con practice. You're going to practice similar triangles too. And fun fact of the video, did you know that in the U.S., people eat more, wait, did I use this already? Yes, sorry, I already did this one. The one, what was it? It was, oh yeah, it was a mouse can fit in a hole the size of a popcorn. Fit in a hole the size of a popcorn. Pretty impressive for those mice. All right, yay for similar triangles.